All right, welcome back. We were talking about loops, and we are going to continue with them. Uh, but a little short interruption. We interrupted this message to talk to you first about the midterm and some extra credit. So let us go there first. To Canvas. All right, so eventually I'm going to make this midterm 1 module available to you, and it's going to have all this stuff. The most important things for you right now is the midterm 1 info and also the extra credit assignment. Okay, so let's go to both of those. First things first, the midterm is going to be available on Canvas between 2:30 p.m. on the 18th and 5:30 p.m. on the 19th of February. So those are Thursdays and Fridays. So there's the 18th, there's the 19th, Thursday and Friday. You can start whenever you would like in between this window. But once you click go, you have only an hour and 15 minutes to take the exam, so like a normal class time. Okay, so just make sure to start at 4:15 on the 19th if you're gonna wait until the very end of the range. Okay, just to make sure that it doesn't stop it for you. All right, so that's that. Midterm 1 is going to take place during lab, so there will be 2 lectures, but no new lab that week. Okay, I'll extend the one that's out there if I do release another. Okay, so that is logistics. The topics, everything will be from the following. So lectures up through week 5, not including functions. We're going to talk about those maybe if we have time. Arrays and vectors are going to be the last potential topic that appear on the midterm. Okay, and all the stuff from your zybook readings and your zyb labs, I'll be taking things from chapters 1 through 4. Okay, so go ahead and study those, and that's where I'll be taking things from, as well as labs 0 through 3, and those are the virtual machine labs. Okay, so this is going to make up the content that's going to appear on the exam. So if you study all this stuff well, you will be set. So here are some topics just listed out that you should definitely be familiar with. That can definitely appear on the exam, and yeah, that's that. So it's going to have a bunch of multiple choice questions and then fill in the blank and coding questions. Okay, so just a little bit of every kind of thing I can throw at you. One thing that I do want you to prepare to do is to paste code into a text box on Canvas. Okay, so just get really, really good at copying and pasting between like Visual Studio Code and Canvas, okay, and somewhere else. Okay, finally, I'm not going to make you do Proctorio or anything like that. That's weird. The test is going to be open book and open notes, so go crazy, but not open Discord. Okay, so don't try and talk to another human, because then you will face my wrath. All right, but you can use all the notes and your textbook. So that is the midterm. Please yell at me if you have any questions about it, and let us move on now to your extra credit, which is hopefully going to help you for the midterm. So I want you to make some review materials, for the midterm itself. So this is worth up to 2.5% extra credit on top of your grade. So like if your final grade is 88%, then if you do the full credit for this one, it'll bring you up to 90.5%. And just watch out for late submissions. Those are not going to be allowed because this is extra credit. It's going to be due February 17th at 11:59 p.m., so right before midnight. Okay. Yeah, so you have 2 options for this extra credit assignment. You can make a review video, or you can make a review write-up if you would prefer to not record yourself. So if you're going to make a review video, just like come up with a bunch of topics that might appear on the exam, and then like demonstrate them. Go through those examples that you made, solve them, do whatever, explain them, and yeah, that's really all. Make a nice review video that would help you to study and also your peers to watch, and post it here. To get all the 2.5% extra credit, make a 20-minute video. You don't have to like edit it or anything, just post the raw video. And then if you want half that, you can make a 10-minute video. Okay, so consider doing that. And I can help you record yourself if you'd like. I use a program called OBS, and even Zoom lets you record yourself. Option 2, if you'd like to write instead of record, you can essentially do the same thing. Make up a bunch of examples for things that might appear on the exam, and like explain how to solve them. Overview a certain thing that might appear, things like that. Definitely provide a bunch of explanations to like help you as you're studying, and also your peers when they read it. Okay, so that is the write-up version, and if you want 2.5 extra credit with that, make a write-up including at least 500 words, okay? And that's also including code, so you can just like paste that into Microsoft Word and have it count your code as words. I do not mind that at all. So yeah, and if you want half that, do half the number of words. So those are your two options for extra credit, and if you do, you can only do one, of course, and if you do it in full, you can get up to 2.5% extra credit. So do consider doing that. Okay, so that is the midterm stuff. And now let's get to the normal topics. So I do want to warn you, I'm about to use a different editor in this class. I'm not going to use Visual Studio Code anymore. I will use my own. Okay, and I'd be happy to teach it to you or show you what other editors have to offer. Please come to office hours or yell at me on Discord about that. Okay, so now, remember how we were counting up last lecture? Let me show you how to count down. So like instead of going from 1 to 2 to 3 to ... to 10, let's go from 10 to 9 to 8 to ... to 1, yeah? And again, this is achieved the same way. You still have a starting variable, some variable called I that you keep track of your iteration in, and instead of starting at 1, just start at 10, yeah? And then you can, instead of, print it out, and instead of like adding 1 to this, subtract 1 from it. Instead of incrementing, we say decrement instead. So then print the 9, then make it 8 by subtracting 1, print the 8, ... all the way to 1, print the 1, well, eventually print the 1, then subtract again to know that you're done, and that will stop the loop. Okay, so that's essentially the idea. I'm going to show it to you in a while loop and a for loop. Oops. Because why not? Okay, so let's get started. So this is a command that I've made for myself. I can add it for you if you'd like. I just made it be called E for edit, but this does not exist on your computer right now. Okay, let's edit a file called countdown.cpp. Yeah? And let's, I guess, first do the while loop form. We're going to start our I at not 1, but 10. Because we're going to count down. And we're going to say while. We want to use I to count down and keep printing I while I is, well, not like less than 0, but like greater than 0, greater than or equal to 1. So I should go between 10 and 1. Okay? And then we're going to decrement I by saying I equals I minus 1. But alternatively, instead of this, you could say I minus minus instead of I plus plus. That's equivalent. And then, let's see, the meat of this is to say cout I. So print the actual value of I. I starts at 10, starts out being greater than 1, of course, greater than or equal to 1. We print the 10, make it 9, 9 still greater than or equal to 1, print the 9, make it 8, still greater than or equal to 1, so on and so forth until I is 1, print it, make it 0, that stops the loop. Okay? I hope that makes sense. So I is 0 now, and that's what stopped the loop. So let me show you this. G++, well, I can just probably do this. So we can say countdown.cpp-o countdown. And bam, we're going all the way from 10 to 1. Beautiful. And now let me prove to you that I is 0 right now. Hey, that's what stopped the loop, because now it is less than 1. Cool, huh? So let's print a new line to give ourselves some space, and let's do it the for loop way now. And remember, for loops, they have initializations, conditions, and increments. You kind of like put all these things that used to not be inside of the while loop's parentheses into the parentheses, and then the body is slightly smaller because you don't need the increment inside of it anymore. Okay, so for initialization, condition, increment. Ready? Let's say j instead of I. J is 10, j is greater than or equal to 1, but equivalently, we could say j is strictly greater than 0. That's equivalent. J minus minus, and then we'll say cout j, new line. So this is all the same. Start j at 10, make sure it's greater than 0 strictly. Print it, subtract 1 from it to make it 9, to make it 8. All the way down to 1, make it 0. 0 is not strictly greater than 0, so we're done. Okay. Hey, and so we have the same thing. So we're counting down in 2 different ways using a for loop and using a while loop. Okay, so hopefully that was fun. Continue and break now are the next things that I want to teach you about, and they are extra fun. Oh, let me check that. Yes. So continue. Well, first of all, I should say that both of these only ever work inside of loops. Like these are new statements that you can have once you're inside of a loop, at least one. Okay. So let's make the first one a for loop demo and the second one a while loop demo for reasons. And so now let's explain continue. So continue is just a statement, like you put a semicolon and everything. Inside of a loop, it skips that iteration. So that goes straight to the top of the loop again to start a new iteration. All the other things that were below it do not get executed. And this is quite nice if you would like to take an iteration and just get rid of it and just continue the rest of the loop as if it never existed. So let's pretend that we hate the number 3 and we'll print from 1 to 10, but we will make sure to continue before ever printing 3. Alright, so let me show you that. Fun little idea. Let's call this continue break.cpp. Here we go. How do we want to do this? So a for loop for int I equals 0, I is, 1. I is less than or equal to 10, I plus plus, cout I. So this will print from 1 to 10, but we don't like the number 3, so we're going to get rid of it. Okay? If I is 3, don't print 3 because we hate it. Okay, so we say continue to skip this loop iteration. It doesn't do the rest of it, doesn't do the rest of the body at all. It goes straight back to the top to do it again with 4. Whee. See how it goes from 1 to 2 to 4 now? Isn't that fun? So continue is nice if like there's one thing that you would like to skip and it's hard to make the loop cleanly otherwise. Okay? It's just a nice easy way to skip one iteration. Okay, so that is continue. Now break is like its fancier cousin. Break stops the loop, so it's a bit more angry. It exits the loop itself, the closest loop. If you're in multiple loops, it executes the innermost loop that you're in. We'll talk about that later with nested loops maybe. But yeah, break exits a loop. Okay, it's like I'm done with the whole thing now. Get me out of here. So as a demo for a while loop, I will show you how to stop a loop when the user types Q for quit, I guess. So I'll say while true. So normally this should never stop, right? But break can stop it. So I can say, I don't know, cout, enter Q to quit, char C, get C, and then if C is equal to Q, we can break, stop the loop. Okay, otherwise it'll just keep on saying enter Q to quit, enter Q to quit. But the second it's Q, we'll break, which stops the loop. Are you ready? So I'm not going to enter Q. A, B, C, D, E, F, G. So you can keep on going. As long as C is not equal to Q, this if statement will never happen, its body will never get executed, and we'll end the loop but go right back up to it because the condition is always true. So the second this statement is true, though, the second C is equal to the character Q, will break and stop the loop. So bam, it finally ended and allowed the program itself to end. Isn't that fun? So that is that's break. That stops things, stops the loop, the closest loop you're in, if there's multiple. And yeah, so that's continue and break. They will come in handy, I promise. And now we're ready for some complicated examples, some fun ones. So a very interesting example, if you are mathematically inclined, is to calculate the number e, which is like 2.7 something, right? So let's calculate it very, very rapidly with this formula, which maybe you've learned in a calculus class if you've taken it. So e is equal to, starting n at 0 and going all the way to infinity, the sum of 1 over n factorial. So 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial, on and on and on until the end of time. So let us code this up in a loop to calculate e. Let's make it easier on ourselves and just go from 0 to 100. That's going to be good enough for our purposes. And so what we're going to do is, well, we'll just calculate each term at a time and then add it to our sum. Okay, so we'll like start a sum at 0, and we'll have our n represent where we're at. Like it'll start at 0 and go to 1, then go to 2, and then go to 3, all the way to 100. And then we'll stop the loop. And then we'll like calculate our current term maybe. We'll be like, okay, current term equals like 1 over factorial of n. Something like that. And let's do double division, of course. And so we'll use the current term variable and just add it into the sum. It's all going to be beautiful, but that's my strategy. Are you ready? So let's do this. I am going to have to secretly write a factorial function first. Don't tell anyone. So let's say here, edit, dun dun dun. I guess e.cpp, why not? So here we go. I'm going to secretly write a factorial function. I'll be right back. Okay, with the magic of pausing videos, I now have a factorial function, and so what I'm ready to do is do the entire thing. I'm going to make some variables. So double sum starts at 0, and we're going to add into that. And then we're going to have a for loop that iterates 100 times with like a variable n, starting at 0 all the way to 100, n++. And then we're going to have that current term variable. Current term equals, I don't know, it's going to have to be 1.0 over n factorial, right? So this will be first 1 over 0 factorial when n is 0, then 1 over 1 factorial when n is 1, then 1 over 2 factorial when n is 2, and we'll just keep on adding that into, remember, this sum variable, because current term will be different each time. Okay, so that's essentially it. Let's see here. Now we're going to do that 100 times, and I guess that's that. So sum equals sum, whatever it was, plus current term. We're going to get closer to the answer that way. Okay, so at the end of this, once we've gotten past 100, now sum should be very close to e. So let's print it out. All right, and you can see me testing it beforehand. Hey, oh man, do we get e? And that's very accurate. It actually converges very quickly. We didn't actually need to go all the way to 100 even to get that many decimal places. So isn't that fun? We have calculated e ourselves, okay, using a loop. Isn't that awesome? And then finally, as a nice little example to end us off, it's a bit easier to think about, I'm going to make a cute little star that falls from the sky. Or maybe it's a line that we're drawing. So it's a star then it waits a little bit and gives us another star, then it waits a little bit, gives us another star, and just kind of falls or draws a line, depending on how you think about it. And we'll use that pause function that I had from the very start of class for that frozen example. So let's go back to there and steal it. So I'm first going to need, actually, let's build it. I'm first going to need like a file. Let's call it animation.cpp maybe. And then I'm going to need that function. So let's go to CSCI 40, lecture 1, karaoke, pause. Hee. And it needs these two headers as well. Cool. Copy paste. So now, look what I can do. I can say cout, cute little star, character, and a new line. And then I can pause for a little bit, a certain number of seconds, like, I don't know, 1 second. And then I can do it all over again. Watch this. See how it's drawing the star ever so slowly? It's so cute. And of course, this is repetition, and we can make this better with a loop. So instead of all this, let's bring it into a loop, please. Or let's do a for loop. Int I equals 1, I is less than or equal to 10. Oops. I plus plus. And then we'll do this entire thing inside of here. Yeah, so now it'll draw that cute star 10 times and pause for a short amount of time after drawing it. So look at the cute star falling. Isn't that cute? Okay. You can, of course, speed up this animation if you would like. And one way to do that is to, well, I guess the only way to do that is to change the argument to pause. You can say, no, wait only half a second in between drawing your stars, so it'll fall faster. It's a windier night. Isn't that fun? So it's kind of soothing, I guess. But that is animation. That's using loops to do fun stuff. So I hope some of this is getting ingrained in your mind, and it's starting to be a little bit fun at least. And so now that brings us to our next topic, and I want to warn you, unfortunately, this is historically a very difficult one to learn. So maybe pay a little bit more attention than usual for this particular topic. It's nested loops, so loops inside of loops. I'm very sorry, but it has to be done. So the idea is, when you have a loop inside of a loop, you can think of it as just, well, another giant statement that gets executed, right? But it has to be executed to completion. It has to be executed to completion, which means that, well, you got to do the whole loop each time you execute one iteration of the outer loop. The entire inner loop gets done. Okay, so yeah, during each iteration of the outer loop's body, the inner loop executes completely. So just think of it as one big statement that just gets done. And I'll have plenty of examples to help you understand this. The first one is probably the most important. So here's a nested loop, and we're going to walk through it very, very slowly. So I'm going to copy and paste it, and we're going to run it, and we're going to talk about why it's doing what it's doing. Okay? This is actually the output over here, but we'll get there. So, nested loops.cpp. Oops. Go back and copy and paste. When I delete stuff in this program, it copies it automatically. There we go. So, oops, these are fancy quotes. We don't like those. Now I think it's going to be happy. So I'm going to run this after I compile it. So here's what it does. This is what it prints. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. Interesting. All the way to 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. Okay, so that's the output. This is the loop. Let's talk about why it's doing this. So this is a loop inside of a loop. Do not be scared. So what is this outer loop doing is the question. Maybe take a second to pause and think about it yourself. Well, if you think about it long enough, well, it's just executing its body 5 times, right? Because I is going from 0, 1, 2, 3, all the way to 4, yeah? It can't hit 5 because it's got to be strictly less than 5. Okay, so that means it executes body 5 times. Okay. How about this inner loop? How many times does it execute its body? And remember, the outer loop's body is this whole thing containing the inner loop. Well, it also executes 5 times. Same for this one. It's also executing 5 times. Okay, if that is true, let's see. This gets executed 5 times, which means this whole thing gets executed 5 times. But it itself executes its body 5 times each time it itself gets called. So that means, and this is the key idea that I want you to remember, that this inner loop's body, how many times does it get executed? This line gets executed 5 times 5 times. Okay, that's the key. This loop, this outer one, whose body ranges from here to here, this whole thing, it executes 5 times. Which means this entire loop gets executed 5 separate times. It's like if you copied it 5 times on top of itself. Okay? Which means this inner loop here gets executed 25 times, because it's 5 times for each of these, and that whole thing is happening 5 times. Okay? Hopefully that's making sense. I know it's weird. Eventually it will. It will all come together. And now why does it give us this output? Why is it doing that? Well, it's going from 0, 0, 0, 1, 0, 2, all the way to 4, 4. And here's the idea. Let's walk through it. So you've got your 2 variables, I and j. Are you ready? Here's the idea. So maybe I'll use this arrow actually as my guide. We start out with I equal to 0. And we keep on going while I is less than 5. Cool. And then we execute the body, which involves executing a whole other loop. So, okay, that involves setting j to start at 0. Fine. And j is less than 5 currently, so we're going to execute its body. So now I have I being 0 and j being 0. Okay? And then we're going to execute this line, which prints, oh man, 0, 0. Hey. And then we're going to come back and be like, okay, back to the loop, because this whole loop needs to execute before before the body of this outer loop is done. We have to finish executing this entire loop, and it's still got 4 more iterations, yeah? So we're going to say j++. Okay, now it's 1. Cool. See out ij. So we have not touched I ever yet, not again. I is still 0, now j is 1. So that's why we print 0, 1. Okay, hopefully this is starting to make a little bit of sense. Then we come back. Well, j++, j is now 2, it's still less than 5, print ij. Yeah. And I think you can see this is going to go 3, 4, and then it's going to be done. This entire loop is finished because now j is 5, 5 is not strictly less than 5. I'm done with this loop. Okay, so which means I'm done with 1 iteration of the body of the outer loop. Okay, so now I come back to right here and worry about I again. So kind of like reset j doesn't even exist right now, honestly. And now I is 1. I++, I is less than 5, cool. Back to this, I'm going to execute the body of this loop, which means, well, execute this entire loop. J is 0. Well, it's less than 5. Print I space j. Well, 1, 0. You see the game that we're playing here with this nested loop? This entire thing needs to get executed before we go and do the next iteration of the outer loop's body. Okay, j++. Now it's 1, 1. You see that? 1, 1, 1, 2, 1, 3, 1, 4. And then we're finally done with this loop again. Come back out here, increment I. So now that I is 2. And then we do 2, 0, because we set j back to 0 to do all this over again. Okay, I hope you see where we're going with this. And then we do 2, 1, 2, 2, 2, 3, 2, 4. And eventually, you're going to get all the way to 3, like, I don't know, 4. So I is 4, j is 0, 1, 2, 3, 4, print 4, 4. And finally, done with this inner loop, because j is now 5. Done with this outer loop, because I, you're going to increment it and make it 5, and now you're done. You're done with the entire thing. So this does take practice. It takes staring at this. This is a very, very good example that I want you to understand. So please try and get it into your mind. Come yell at me if it's not making sense. This is what I want you to understand. Okay, so yeah, the key idea is this inner loop right here gets executed once each iteration of this loop right here. Okay, so with that, it's going to execute its inner line, the body of the inner loop, 25 times, because this executes 5 times, this executes 5 times. So that is enough talking. Let me write some stuff down. So the key thing that we just learned is that nested loops multiply work. They multiply the amount of work done. So we're going to take that into advantage and draw a box now. We're going to draw a box of stars. So first we'll draw this, and then we'll draw a fancier one. So what I would like to teach this to you as is the following. So again, there's going to be a nested loop, and here's what needs to happen. Let's say that the outer loop, let's have that deal with which line we're on. We'll say it worries about what line we're on. And then the inner loop will actually deal with drawing the stars. Okay. Printing a line of stars. Okay, so the idea is like, okay, the outer loop has an I starts out being 0, and so then I will use my inner loop to print 4 stars. And then I equals 1. I will use my inner loop to, again, print 4 stars, things like that. And then finally, I equals 3. I'll print 4 stars, and then I'm done. Okay, so let me show that to you. This is the idea. So it's, okay, do 4 times the following. This is one loop. That's like the outer loop. And then, so 4 times I want to print 4 stars. Yeah? I hope that makes sense. So inner is, again, do 4 times, print a star. And then once this is done, I've printed 1 line of stars, I'll print a new line. Okay, so that is the idea. So this is going to worry about printing 4 stars, and this will print my new line. And so 4 times, if I do that, I will have a 4x4 box. I hope that's making sense. Now let's do it together. Let's do it with some for loops. So let's say box, or maybe we'll do both boxes in the same file. So here we go. So the outer loop keeps track of which line we're on. And normally people like to start their iteration variables at 0 if they don't ever use them. I is less than 4, I plus plus. This iterates 4 times. And then, so what I need to do is 4 times I want to draw 4 stars, or create a line of 4 stars, which I think you know how to do with just a single loop for int j equals 0, j is less than 4, j++, we'll say cout star. That prints 4 stars. This whole thing right here prints 4 stars, and then we'll print a new line. Okay, so again, 4 times do the following. Think of it like this. 4 times do all of this. So print a line of 4 stars and a new line. If you do that, you'll have a box. All right, so I hope this is making some sense. It's just 4 times do everything inside of the body of this loop, which itself worries about printing 1 line of stars and then a new line. Okay? So that's fun. We can use that, use that same code to draw this box instead. And the only difference is sometimes we have stars and sometimes we have spaces. And we need to figure out when we have those spaces. So what are the ij pairs that make these spaces happen? Okay? So what are these 4 ij pairs? Because then we can like have an if statement and say, okay, if I is this and j is this, print a space instead of a star. And well, using this information, we'll be like, okay, the I must have been 1 or 2, and the j must have been 1 or 2. Because it's 0 here and 0 here, yeah? So if I is 1 and j is 1, or I is 1 and j is 2, print a space. Similarly, if I is 2 and j is 1, or I is 2 and j is 2, print a space instead of a star. So look how easy it is to take this and then make some small changes to make it hollowed out. So instead of drawing a star all the time, we're going to check if we should draw a space or a star. If I is equal to 1 and j is equal to 1, or I is equal to 1 and j is equal to 2, things like this. Okay, so there's a bit of a cleaner way to do this, and if you think about it long enough, you can come up with this. If I is less than, how about greater than or equal to 1, and I is less than or equal to 2, and j is greater than or equal to 1, and j is less than or equal to 2. In that case, print a space. Oops. Print a space, otherwise, print a star. Okay, so this condition right here is saying, okay, is I in between 1 and 2, and j also in between 1 and 2? That's a cleaner way of saying, okay, yeah, I is equal to 1, j is equal to 1, or I is equal to 1, j is equal to 2, etc. Okay, so now we just have to control whether or not we draw a space or a star, and that will give us our answer. So I hope you see this. So in these cases, when I is equal to 1, j is equal to 1, I is equal to 1, j is equal to 2, I is equal to 2, j is equal to 1, and I is equal to 2, j is equal to 2, we're going to draw a space. Otherwise, we'll draw that same star, and that will carve out that part of the box for us. Okay, so hopefully you're starting to see the power of nested loops. Okay, moving right along. The final thing that I would like to show you here is a very, very fun idea. So again, another key idea is that nested loops try all the combinations of values in addition to multiplying work. So you see how I ranged between 0 and 4, j ranged between 0 and 4, and this printed all the different possibilities between 0, 0 and 4, 4, all the way between 1, 2, 3, and 4 for each variable. 0, 1, 2, 3, and 4, sorry. It tried all of those. So, oh man, we can take advantage of that. We can try all the possibilities to solve a particular problem. Our computers are so powerful that we don't have to get fancy about, okay, let's see if we can solve this equation very, very efficiently. No, we can just try everything, every different possibility, and get to the answer of something. So here's my fun problem for you. Let's pretend that we are a farmer, or there is a farmer, and horses cost $10, pigs cost $3, and rabbits, well, they're only 50 cents. Sale on rabbits today. And a farmer goes and wants to buy 100 animals for $100. That's all we know. The farmer went and bought 100 animals for $100. How many of each animal did she buy? Oh, which one? Which ones? There might be multiple different ways to do this. So, the goal is, just like here, I and j range between all the different values that they could be between 0 and 4. Well, let's do this for horses and pigs and rabbits. Yeah, let's have a variable called h and p and r and have it range between 0, 0, 0, 0, 0, 1, because you can have 0 of them and 100 of all the others, all the way down to 0, 0, 2, all the way down to like 100, 100, 100. One of these has to have the answer, right? Let's try all of them. Our computers are fast enough. Okay, so this is what we can do. We can be like, all right, num horses, that's an iteration variable. That can range between 0 and 100. Num pigs can do the same. Can range between 0 and 100. Num rabbits can also range between 0 and 100. Oh, so what this needs now is not a doubly nested for loop, because we have 3 options. We need a triply nested loop. To try all the different possibilities. To try all combinations of 3 numbers. So you could potentially buy 100 horses, 0 pigs, and 0 rabbits. That's the idea. You gotta try 100 of all of them, because you might need just 0 of the other. It might work out that way. So our possibilities must lie within this range. So if we can solve this, we found the answer. Are you ready? I don't know. Brute force. And this kind of algorithm it's called brute force, because we're throwing our computer at the problem. We're not trying to be fancy or efficient. We're just trying all the possibilities. That's what a brute force algorithm does. Okay, so let's do exactly what I was setting out to do. For int num horses equals 0, num horses is less than or equal to 100, num horses plus plus. So that tries all the horses between 0 and 100, because maybe we needed a certain number of those. And it has to be within that range, because you can't have more than 100 animals. That's one of our constraints. And we'll do this again for pigs and rabbits. So let me replace horses with pigs. So num pigs, and then num rabbits. And I think you can see why I'm not using Visual Studio Code anymore, because I can do cool things like that. Okay, so now I'm trying all the possibilities. This line will get executed 101 times 101 times 101 times. That's a lot of times, but our computers are quite fast. They can do that without a sweat. And num horses will range between 0 and 100, and same for pigs and rabbits. So I'm going to try all the possibilities between none of each animal and 100 of each animal, and if there is a solution where I just spent $100 and I bought 100 animals, I will find it. Okay, so now all I have to do is check. Check and see if my current choice, because it will eventually range over all of them, current choice of horses, pigs, and rabbits, check if that current choice is 100 animals and $100. If so, we found a solution. Okay, so that's essentially all we need to do, and it's just an if statement. So let's do it. If num horses, if I just bought 100 animals, so that they sum to 100, so they sum to 100, and the price was right. So horses times 10, pigs times 3, and rabbits times 50 cents. How about, you know what, how about I do this in two variables, like int animals, num animals equals num horses plus num pigs plus num rabbits. So that's num animals, and then also double price equals num horses times 10 plus num pigs times how much? $3 times 3 plus num rabbits times 0.50 for 50 cents. Okay, so that's the price of them that we bought them for. And now if num animals was 100 and the price is $100, then I found a solution. Because the number was 100 and the price was 100 in that one case. Let's print out what we bought. This was num horses, comma, space, num pigs, comma, space, and then num rabbits, new line. Okay, so that is the answer. It's going to tell us the answer if we found one. And it's going to range through all of them, and so we're guaranteed to find all the answers if there are some. Okay, there might be more if you could have fractional amounts of animals, but we're not going to go there. Okay, yeah, I think that's everything. Let's run this. Hey, so it looks like there's two solutions. Fancy. What are they? Let's confirm that there are solutions. So you could have 0 horses, 20 pigs, and 80 rabbits. Is that correct? 20 times 3 plus 80 times 50 cents. Ho ho, that is 100. Cool, cool, cool. And this adds up to 100. Yes, so does this. 94 plus 1 plus 5. Does that also add up to $100? 5 times 10 plus 1 times 3 plus 94 times 50 cents. That's a lot of rabbits. Wow, that's also 100. Hey, so we found the two answers here. You could potentially have 0 horses, 20 pigs, and 80 rabbits. That would fulfill the requirements. Or the farmer could have bought, she could have bought 5 horses, 1 pig, and 94 rabbits. Hey. Okay, so that is the world's coolest example, I think, and it just goes to show how nice nested loops are sometimes. They are hard to wrap your mind around, I know. Study this example, though, to see how it's ranging its I, make it small, I and j between all these values, and it's trying all the possibilities. So, key ideas. Nested loops multiply work so that you can draw cool boxes, and they also try every combination of values so that when you have a problem that requires a specific kind of solution, you can try all of them, and rest assured that you will find every solution, if there is one. Okay, so that is nested loops. That is the last thing that I want to talk about today. When we come back, I'm going to show you how to graph things on the terminal. We're going to make our own graphing calculator out of the terminal, which is really fun, using cout and everything, of course. And that will wrap up these slides. So I will see you back for cool circle graphing. See you then.